Welcome all. How many new people? Any new people tonight? Oh, there's lots. Oh, look, there's all sorts of new people. Welcome to the new people. For those of you who don't know me, my name's Greg. I'm one of the organisers of the Power BI Melbourne meetup. So if you're here for Power BI, you're in the right place. We also do Fabric, so that's a thing. Hello, online people. Nice to see you again. It's great. It's always great to have you all here. It's wonderful to see everyone in person. We're getting our in-person meetups. There's more and more people showing up, so it's great to see. I've got a great presentation tonight from an experienced presenter and a long-time member of our meetup, and so we're looking forward to hearing from Michael. But before we start, a couple of things. I wanted to say thanks to Cognizant for the venue, this lovely office. Well, and thanks to them for hosting the meetup, and they also supply the drinks. And also thanks to serious people who are tech recruiters. There's Bryson at the back there. If you're looking for a job or you're looking for people, then talk to Bryson. And if you're in the enterprise data space, I mean, Cognizant's obviously a massive organization. They do everything, but put them on your list in your Rolodex if you're in the enterprise space and you're looking for help there. June update for Power BI, we had probably the biggest thing, the most interesting thing to me was the PBIR format. So that was a new piece. So that's included in PBIP, so the new Power BI project file. If you guys are interested in kind of CI/CD in Power BI and what's happening in that space for project files, I'm doing weekly Friday lunch and learn sessions on Teams. So you can find those on the same meetup that you found this one. Come along to the lunch and learn. We're trying to figure out how to do a CI/CD, Power BI, Fabric, budget and forecasting, Excel madness is happening. It's a lot of fun. So join us. That's at 12 o'clock every Friday. We're doing that at the moment. So if you're interested in that and having getting involved, then that'd be great to see you all there. All right. I think that's it. Without further ado, I want to introduce Michael. Michael I'm sure, will give you a bit of history of himself. He's going to talk to us about rocks and results and Power BI. So give Michael a hand.
Thanks, Greg. Yeah, so as Greg said, I've been attending for a long time. My first time here was actually seeing Greg give a presentation of live sensors and stuff, and that's what that's what got me hooked on Power BI. So that was all the way back in 2016. So it's been a while since then. And so myself at the moment, I'm working for a utilities distributor from New South Wales called Essential Energy. But previously I was in consulting and I spent the last 6 years or so in mining. So as I'm moving away into utilities, I thought it was a good time to kind of collect my thoughts together, and that's what I'm going to talk about tonight. So I'm going to be talking about some of the specific mining terminology that you'll hear if you get involved in this industry, and then some of the KPIs, the sorts of things that we measure when it comes to mines. So that was my ode, so my first foray into mining was back in 2017. So I was brought into mid-tier mining company to do standard sort of ERP reporting. So they had some SAP data and they wanted to just do some financial sort of stuff on it, proof of concept on Power BI. Now they obviously liked me because 6 months later they brought me back to backfill the position because as was happening at the time, Power BI was just growing and growing within organizations kind of organically outside of the standard IT teams. So I was brought into the digital transformation team at the time to extend their Power BI capabilities. So as I started to begin to familiarize myself with these the mining industry, because the first project was more on the ERP side, but then my first project when I was brought into the digital team was around a system called Ampler. So they have this system called Ampler, which takes the measurements from the processing plant and so they have a SCADA system which takes all the sensors in, and then they run some algorithms through this Ampler system, which gives them performance on the actual plant systems themselves. So you'll have things like availability and utilization, throughput rates on the actual systems themselves. As with any new industry that you're coming into, it's going to be complex. You know, you have so much to learn. There's all these different acronyms. You've got all these different metrics that people are throwing at you. The data's never clean. You know, you're running into all of these challenges, and that's exactly what I started to run into in that first. Good song. So to try to get you a head start, if you are looking into the mining industry, I'm hoping to unpack some of those mining terms and explain a bit about the mining process from the stuff that I didn't know before I jumped into mining. Now, this is a rough grouping of the kind of value chain of mining, where we'll start at kind of the start of the first process, and we'll kind of work our way through how it all kind of hangs together. So the first part is exploration. So what this is, these are geologists, these are data scientists, these are people who are crunching numbers in terms of assay results, drill hole data, the lithography. So we've got up here, this is essentially a visualization of the ore body underground. So you've got dirt, you've got rocks, and then you've got valuable minerals. So what they actually do is they'll have a drill rig on the top with a really, really long core drilling apparatus. And they'll drill cross sections. That's what you've got, those white lines there. And then they'll take these cores. So it's essentially like a big hollow drill bit. And as it goes down, it brings out these long cylinders of the core, so the rock from underground. They then use spectroscopy to kind of trace through the core where all the elements are. So you find your intersection of where each of those elements are. So you can see there's kind of white lines running through, so they're all different minerals. And then they use some really advanced algorithms to kind of build up what they believe is the ore body underneath the ground. And that's kind of the first part. So they call that resource drilling. And then Power BI doesn't want to render. Classic. Let's just drag that over. So that's the limitation we've just discovered, is that we've got these Power BI visualizations that are live imported don't seem to show in the presenter view. So that's something. So these are two of the sorts of metrics that you'd be looking at in terms of exploration drilling. So it's important to get core recovery. So as you're drilling down through and you're removing that core, if that core is getting smashed up, you lose all the information in where the minerals are. So you can't properly build your shape of the resource underground. So that's important. And then, of course, cost is always important as well. So we're looking down here at the rate per shift. So they work in 24-hour time with 12-hour shifts usually. So they'll set the rig up and they'll have one crew come in and they'll be doing drilling. So that would be your drilling rate. And then you'd have your average of the cost it costs you. So you've got maintenance, you've got fuel, you've got the wages. So, and the deeper that the drill goes, the more expensive it gets, basically, because it gets harder to drill the longer the drill bits kind of. They have a drill. It has these drill bits that kind of stack on top of each other, and the more you get, the more tension is on the drill underground. You've got more pressure from the surrounding rock, and it gets more expensive. So the deeper the ore body, the more expensive it gets. So the next stage here is production drilling. So confusingly, they have two forms of production drilling. The first form is in exploration. The second part is in what's called development. So this is another version of what you can see. These are essentially the cores rendered underground. So in production drilling, they're taking their exploration, which is primarily done from the surface, and in the production drilling, they can actually do it from underground, from inside the shafts and stuff like that as well. But these were all from the surface coming down, and they use that to refine the ore body. So at the start, with the exploration drilling, it'll be much further spread out, and then they'll refine where they need to get all of these different cross sections, so they can build up a better estimation of where all the valuable minerals are underground. And so if we're looking at production drilling for exploration, you want to be looking at your variance of the accuracy of the drilling. So what this is talking about is if I planned to drill on a 45-degree angle and I want to go down 400 meters, how am I tracking against that? How accurate was I? Did I only get to 350 meters before I had to stop drilling? Or did the angle start to deviate? Because as you're going down, the drill bits can start to flex and they might go to a slightly incorrect path. So we've just got some variance there. And then down the bottom, we've got the ore grade that you've confirmed. So this is obviously very important. So you want to know, and this is not real data. That's why it's much higher than you'd usually expect. 90%, where 97% ore would be pretty crazy underground. But we've just got a bit of a heat map. I mean, the more ore you've got and the less rock, the more valuable the resource is. Then the next stage is development drilling. So we've now explored, we've built the shape of the ore underground, and now we need to get to it. So what this involves is this process called creating drives. So you can see here on this bottom diagram, this is what's called a drive. And as you're extending the drive, they call it making a cut. And what that entails is getting this big drill. So it's not like the drills that you'd think. When I was picturing someone with like a big hand drill, you know, like just drilling in the rock. But no, they're like big kind of front end loaders with this huge drill on the front. And what they do is they drill blast holes. So they actually have a kind of a formula and algorithm for how they place these holes. And the purpose of it is to make holes deep enough that you can load explosives in there and you can just blow all the rock out. So that's what they call making a cut. And this type of drill, they're called jumbos. Don't know why, but they are. And as you're getting towards, so maybe your ore body's over here, you'll be making a cut in that direction so that you can then do the next stages of the process. So when we're talking about development drilling, you want to know how what your advance rate is. So advance rate is how many meters you're moving down the tunnel with every cut. So essentially the progress that you're making each shift. And once again, they're working in 12-hour shifts. They're trying to get X number of meters by the end of the shift. And if they do the drilling right and the blasting right, then they'll obviously progress down a certain number of meters. You'll often have differences between the different shifts because of holdups or the availability of certain machinery. So it's very common to see people reporting shift versus shift. Another big thing that happens, especially with underground, is you have a lot of machinery breakdowns. Now, with these jumbo drills, one of the common ones that one of my clients was that you'd have the hoses just splitting off. So they need to use a large amount of water to be able to keep the drill bits from melting. So they pump water in as they're drilling. And these hoses often just rupture. And so we had a specific campaign where we're doing a deep dive analysis on who are the crews, where the hoses were splitting, how much this was actually costing us in terms of the advance rate, but also just so the equipment availability is a really important thing. If the equipment's not fit to progress, then obviously you're going to be held up. Now, once you've made that cut, as you're progressing down the shaft, you're making that shaft longer, you need to secure it. Now, in Australia, we've got really high standards when it comes to safety of underground workers. And so you're not allowed to move into what they call unsupported ground, which would be where you don't have this bolt and mesh. So you can see in this picture, it may be hard at the back, but essentially you've got big wire mesh that you then get a big bolt, which he's got loaded into his cable bolting drill here. And they essentially go up and they just kind of, it's almost like a push stud, like they shoot it into the wall and they hold it there. In other places with more unsecure ground, they'll be using things like something that they call shotcrete, which is kind of like instant dry cement that they spray on the walls, and that it helps support the tunnel. You may not think about it, but underground you actually get a ton of pressure coming in from the sides, and if you don't reinforce the shafts, and even with enough time, with all the reinforcement, you'll see that the tunnels start to bow in because all the weight of the rocks surrounding it will kind of push it in. So the cable bolting comes in and staples these mesh to the walls of the shaft to make sure that you can progress further down the mine. Now, some of the metrics, so similar to before, the maintenance is really important. So the availability, a function of the availability will be how many downtime hours you're going to have. So if the machine breaks, because it will, how long are you taking to fix that machine? Sometimes they can be fixed in place. Sometimes they need to be towed to like an underground workshop. They actually have huge kind of underground caverns where they have a full maintenance workshop set up, and they can hoist the heavy machinery off the ground and make those repairs. But downtime hours is one of the common things that you report against. And then the number of bolts installed and how much that's costing. So the dollars per bolts installed, so that's a function of the repairs and the staff hours, and how much of the mesh and how many bolts you're using, how deep those bolts have to go, all of those sorts of things. Obviously, money is important in every industry, and it definitely is in mining. And then we come to the next set of production drilling. So this is production drilling in the mine. So you already know where your resources are. You've progressed down the mine shaft, and now you want to actually get at the rock that matters. You want to get to the ore. So what they do is they have another type of drill, which I'm pretty sure are called Simbas. Can't remember off the top of my head, but they drill more blast holes either up or down towards the actual ore that they're going to explode. Because they don't, you don't shovel the ore out. You actually have to drill these holes in, blast it out, and then you blow all the rocks out, and that's when you can actually dig it up. So they'll have this drill head, which is drilling up at different angles into the rock to be available for blasting and extraction. And if we're looking at the metrics that matter for the production drilling, you've got blast hole accuracy. So that is how similar to the accuracy with the production drilling from exploration is, are you drilling where you want to drill to? So are you meeting your planned depth? Are you meeting your planned angle? And what's the variance from that? And then you also want to know how far you're drilling every hour. So once again, it's all on shifts, and you're comparing. Here we've got in most of these graphs, for ease of sake, I'm using monthly, but the shift bosses, the people who are running each of these shifts, will be looking at their progress over the last shift, and they have to hand that over to the oncoming shift boss in terms of how far they've progressed, what stage they're at with each of the stopes and the particular crews. So meters per hour as well. And the next bit is blasting. So this is the fun stuff, at least for me. I don't know, maybe that's just me. But this is using those explosives to blow up the ore that we then want to extract. So it might be a bit hard to see in the from the back, but they have all these cables running down here, and that's how they trigger all the explosions. So they've done the production drilling up into the ore body, and then they've come and they've loaded all of these all the holes with the high-powered explosives based on the shape of the ore underground and what we'll get to in one of the next slides, which is the shape of the stope. And so what's going to happen here is they have a shaft at the top and they have a shaft at the bottom, and they've drilled down from the top and from the bottom, and they're going to explode it, and it's going to all fall down into this tunnel. Now, blasting has a whole heap of downstream consequences, so it gets planned thoroughly, depending on where your kind of how big your mine is and where you're doing your drives and all of that. Everyone has to exit the area, obviously, not just because of the explosives, but because the explosives actually suck all the oxygen out of the tunnels and fill it with dust and everything. So there's a clearance amount. So often they'll be doing the blasting at shift changeover when people are coming back up to the surface, because there's less people at risk in the mine. And because it's all high-powered explosives, you've got multiple sign-offs. You've got people who are, you need special tickets to be able to get the explosives out of the inventory and all of that. Yeah, so it's all going to fall down into the shaft here, and that's when they can extract it out. Now, when you blast that rock, if you use too much explosive, you'll end up with too fine of a material. And if you don't use enough, it'll be too coarse. So there is a bit of an art, there's science behind it, but there is experience involved in getting the right fragmentation size. The particular minerals, the composition will all change the amount of fragmentation size. You can fit, if something is blown up more, it's actually heavier because you can fit more kind of in the same area. Sometimes they also cheat depending on the mill throughput. They actually want it even smaller, so they'll use it'll be cheaper to use more explosives and get a finer fragmentation than it is to spend the electricity to mill it up to the particular size that you want. Yeah, so fragmentation size is really important. And then the time delays between when you've actually fired your stope and when you can get back into the mine and turn that stope over is really important. Obviously, if you're having a 24-hour delay between when you've blasted and when you're getting back in there, you're losing a lot of production. Now, depending on the mine, some places will blast in one area and they can let it kind of settle, and they can be mining in another area and it's less important. But in some areas where they only have one drive with one part they're mining, it's very important that you turn it over really quickly. Now, this is quite a confusing concept, or at least it was for me, is there's this thing called a stope. So the stope is not actually, the way they talk about it when you're talking to the miners, they talk about it like the bit that you're getting, like all the ore that has come out. But the stope in the definition is actually this void that's been left at the end. So when they're planning, they'll talk about planning out the stope. But what they mean is all this blasted ore. But the actual definition of the stope is that void that's left behind. So you can see this was the drive above, and these are the drives underneath. And they will have drilled down and blasted from the top and drilled and blasted from the bottom. And all of the ore has turned up in this drive here, and then they'll come in with the what are called boggers, which we'll get to in a sec, and they'll dig out all that rock and haul it to the surface. Yeah, so stope. I always just imagine it as a rectangle, but it can be any sort of thing. But when you're envisioning it, I think it makes it easier to think of it as a rectangle that fits between the two drives and gets exploded into the bottom drive. Now, when they're planning out the stope, they will be estimating based on kind of those shapes that we were talking about at the start with the exploration and the production drilling. Now, they will estimate how much ore they think is in the stope. And then they'll be tracking, how much did we think we were going to blast out? How much have we actually brought to the surface from that stope? Now, this gets really confusing because they have stockpiles underground, so they may dig out some of the ore and place it in a temporary place underground and then bring it to the surface later. Or they may use too many explosives and get too much dilution coming into the stope, so you bring more to the surface. So something that they do track, this isn't a great representation, but they track what they planned versus what they actually got from the stope. And there's some really cool technology in mining where they have the surveyors going underground with these kind of hardened drones. They're like drones in like a cage, and they fly through the tunnel and they use LiDAR to kind of get the entire shape of the whole stope. So they fly it up through the void, or well down, sorry, they'd come down through the void and measure kind of what's come out and what's left. And then they compare it to that block model, which is the shape, and they say how much they think what they estimated were there, and then how much is left, and then they track how much they feel is going to be left to retrieve from that stope. And then obviously the total ore extracted is really important. Now another little fun term is a hanging wall. So the hanging wall is just the part of the stope that's kind of on top. And then the footwall is on the way. Even if it's mostly a straight thing, one of them will be slightly tilted in one direction. That becomes the hanging wall. So you can see in this little diagram here, this is an open pit, but they're moving down through the different levels, and it's the same sort of idea. So the problem you have with the hanging wall is that because it is hanging there, you can get dilution, which is rock that you didn't want, that is not ore, that you now have to dig out because it's fallen off. You also end up with structural issues and stuff like that. If you've got really loose material that you're digging in, like really sandy soil or something like that, you're going to be at more risk of this hanging wall falling in. And so, as I was just talking about, dilution is one of the biggest problems that they're always trying to solve, and it's just a really gnarly problem because you don't know. They're estimating what the ore is, they're estimating what the rock is going to be, but at the end of the day, you're using explosives and you're blowing this rock up. There's going to be some of the rock that comes that you didn't want, and that's what's called dilution. And then once you've fully excavated that stope, you've got to monitor the deformation. So deformation is like what I was talking about with the cable bolting. The rock starts to bow in because the pressure from all the surrounding rocks starts to push it in. And you need to be monitoring how quickly that is moving in, because you may be at risk of a collapse. If that starts to move in really quickly, we're measuring in centimeters here because it really matters. Before you manage to get your backfill in, which is the next thing, then that's a real risk. So waste is dilution, or waste is the rock that we didn't want. This is part of it. It is, as I said, it's an estimation game of where you're doing. So here you've got the ore body traveling along through the middle, and then you'll have a planned dilution, or the estimation of what will actually be waste when you get it out. They estimate that. But then you've got all this stuff on either side that you're not estimating you're going to get out. But sometimes it comes through. There might be part of the hanging wall. You've used too much explosives. You haven't used enough explosives. But waste is a problem on many angles. You don't want to be hauling this because it takes extra fuel. You don't want to be milling it because it is going to take extra electricity. You don't want to be putting it through your processing plant because it's just wasted dirt that is now coming through all of the different processes. So reducing the amount of waste and increasing the amount of ore that you get out from each stope is one of the really active parts of the kind of data science community and geology in mining. So pretty basic, just the volume of the waste produced. They do sometimes care about the waste that you can recycle. So you can use it as part of what they call backfill, where they put it back into the stope and fill it up to support the ground. But primarily you just want to reduce the amount of waste that you've got. Speaking of backfill, there's many different types of backfill. But here in this diagram, we've got this idea of paste backfill. So you'll combine some of that waste material that you have mined, and you'll mix it with a cement mix, which they call paste, and they'll barricade the bottom drive, and then they essentially just pour concrete or this paste mix into the open void, so the stope, and they just fill it up. The reason for doing this is to support all the ground, to make sure that you don't have collapses, so that you can get to the next stope. Usually the way they plan the stopes is you'll dig the drive all the way to the end of the ore body, and then you'll kind of mine back from it, so that you mine it out, you fill it, and you wait for it to set. You go mine somewhere else, you come back and you blow this up, and then you get the problem sometimes of you'll now have overbreak or dilution coming from that paste if it's not set hard enough. Different mines do different things. Sometimes you just have what they call rock backfill, which is just that waste dirt they just pour back into the void, because there is a cost with using the extra cement and the chemicals for doing it. So there is, like everything in mining, there is a balance between the cost of things and what it allows you to do in the future. You can, they do also have labs at some sites which kind of keep samples of all this paste, so they can check at certain times. You know, it's been 100 days since we put that paste in. How hard is it going to be? Is it going to be fully set yet? Can we actually go back and dig through it because we think we need to get to the next part was we didn't plan right, or and so something they care about. And so this MPa is actually the hardness. So this is talking about how set that paste fill is. So they keep those samples, and then at a point in time, they have set intervals. They'll put it in a hydraulic press, and they'll see how much force it can actually undertake before it falls apart. And then we're just tracking the meters squared of the amount of backfill that we've put into each of those stopes. So these will just be all your different stopes. Now, I talked about this a bit earlier, but this is a bogger. So I don't know why it's called a bogger, but it's like a kind of squashed front end loader. So mine shafts are not actually that big because, once again, it's cost constraints. They want to try to keep it only as big as they need. So it's quite a flat front end loader. It's got a big, powerful scoop. And this is what you can see is here a drive. In Australia, I don't think this would be allowed because there's no support on those shafts there, but maybe it's just really hard rock. You can also see here, probably hard at the back, but there's a lot of scratches because underground it's quite dark. It's not actually as light as that picture, and so the guys are driving these and girls are driving these front end loaders around, and they crash into the walls and stuff like that. It can be a real problem underground. So what these boggers will do once the stope has been blasted out, you've got a big pile of rocks now. You need to get that to the surface. So they drive in, they'll scoop it up, they'll either load it directly into a haul truck, or they'll put it on some temporary stockpile, kind of down the drive at a designated place. And when we're talking about boggers, we care about the utilization rate, which is a function of availability. So essentially, utilization is of the time that my vehicle was available, so not broken down, how much was I actually using it? So availability is just, is it down? You know, we usually do something like sum the amount of seconds that it was in down state in terms of the particular measure we're using, and then utilization would be a function of that, saying of that 70% that I was available, how much of that available time was I actually digging or driving around. And then this is the first time we've talked about the the idea of a cycle. So in mining, they have this concept of a cycle, and it's from when the haul truck starts to go down into the mine, gets to the stope, gets filled, and comes to the surface. That would be a haul truck cycle. A cycle for a loader or a bogger would be the time from the haul truck or from the stockpile that they're going to the face to come back and load the truck. And then one of the most I guess important parts of the mining process is the hauling. It's the one that, at least for me, is synonymous with mining. You see these huge trucks going around. In underground mining, they're actually not that big. With open cut, that's where you see all those huge, like, you know, at Rio Tinto and stuff, these enormous things that would just squash a light vehicle. These are more like a kind of tractor size underground, because once again, you don't want to dig anything that you don't have to. And they're kind of reticulated so they can get around corners and stuff like that. But this one's underground. You can see he's full, and you can get an idea of some of the fragmentation size. He's got a big boulder in here, and he's got lots of little rocks. And same down here, you can see kind of a big rock there, and lots of little rocks, and a whole heap of dirt as well. Oh, am I not plugged in? It's annoying. How do I know if that's on? There we go. Sorry, guys. Yeah, so the whole truck will be filled up by the bogger, and it will come to the surface and put it onto a stockpile. Take it. Sometimes they'll put it directly into the processing plant, or if they've got waste store, they'll put it in the waste. Now, you do get some funny things where people put it in the wrong place, and then you end up with waste in your ore pile, or from your ore stockpile, you put ore into your waste pile, which is probably one of the worst things you could do. But in general, that's kind of how that goes. And so once again, we've got the concept of the cycle times. So the shift bosses will be managing people on the cycle times. When you've got, you've got a 12-hour shift, and you've got some funny things where the guys will work out, okay, if I go up, if I take a little bit longer on this cycle, then next cycle I can end up like right at the top of the mine at the end of the shift, and I can just kind of get off. So it's a reporting on the cycle times and the missed opportunity in terms of how many loads that you miss over the course of a week or a month based on people kind of shortchanging these cycles is something that you'll actually see often that the second last cycle of a shift is the longest cycle out of all of the cycles, because they're trying to drive a bit slower, or they get sneaky with it. Another important thing with the haul trucks is how well you're utilizing the load that you're actually doing. So similar to the cycle times, sometimes they'll say, oh, I'm full enough now, let me go now. And then they drive all the way to the surface, which in some mines can take an hour. With 80% load or a 70% load, when they could be pushing the actual weight that they're carrying more, and you get more efficiency out of the fuel. In fact, the manufacturers say you should aim to be average, say 60 tons or something. But if you're pushing it to 62, it's not going to hurt the truck. If you're pushing it to 70, it's probably going to hurt the truck. But you need to, it is a balancing act between underfilling, overfilling, and then these cycle times as well. Now the next part is the processing plant. So you can see here, this is a full processing plant. In here is kind of everything that this site needs to process their material. Depending on the particular mineral that you're mining, depending on the method, you'll have different configurations of plants. I heard about one of the uranium mines. All they need to do is kind of sieve some sand. They just put the sand in the thing and they kind of sieve it, and all the uranium falls to the bottom because it's heavier. Whereas the ones we were familiar with using were zinc, lead, copper, that sort of thing. So it looks much more similar to this. Plants are where they do all the processing, taking it from ore to an actual sellable product. Two really important metrics here: recovery rate and throughput. So recovery rate is of the material that you're estimating is going into the plant, how much are you actually getting out? Because you're pouring valuable minerals into it, but it's actually a really complicated chemical process, and getting the actual ore out of it is once again another sort of budget constraint. You could get all of the minerals out, but it would mean you'd have to mill it much more. You'd use much more electricity. It's going to cost a lot more. You're going to have to use many more chemicals to be able to extract that metal. So it is a balancing act between how much recovery you have and how much throughput you're doing. The more you're putting through and the quicker you're moving your plant, the lesser the mineral you're going to get out as well. So the first part of a plant that the mineral will interact with is the crusher. So usually the haul trucks will often just back straight up to the crusher and dump it in. But depending on where it is, you may have a front end loader on the surface, kind of mixing from different stockpiles like high grade, low grade, medium grade, to try and get the right mix. It's kind of like this weird art cross science sort of thing. And then they pour it into this big chute, and it does exactly what it says on the box. It just crushes the rock. So it's taking the really big rocks and just making it a bit smaller, bring that fragmentation size down a bit, but it's not the same as the mill. And so in the crusher, I think we've got particle size, how fine it's getting, and then the throughput, so tons per hour. They're two of the common things you'd be looking at with the crusher. And from the crusher, you're going into the mill. So it's really hard to get an idea of the scale, but these things are enormous and they move really quickly. When you're standing near them, it's a really intense experience because this whole barrel is just spinning and spinning and spinning. And inside it, you actually have all of these. So this is called a ball mill. There are different types of mills, but it essentially has all these metal balls inside it that you put your rocks in, and the balls get picked up on these little shelves inside the mill as it's spinning. And as it gets to the top, they then fall down on the rock. So you get all these big rocks in there, and as it gets milled, the fine particles kind of move out, whereas the balls stay in the mill. The amount of electricity that mills use is amazing. The milling cost, the cost of milling is probably one of the biggest costs of most mines in terms of just how much electricity it uses. I did see a use case from Newcrest Mining where they actually managed to save $25 million just by reducing the amount of unplanned outages they had on their mill, because the amount of power it takes to get it going again, and the lack of throughput when that mill is down. So you'd be looking at your grinding efficiency, so how much electricity you're using in order to get the right particle size, and then obviously your throughput per hour, how many tons you're getting through that mill. and they're functions of each other. You know, you're gonna, the more time you spend inside the mill, the more you're crushing the ore, the more electricity and costs you're going to do, and the less throughput you're going to get. So it is that balancing act between each of the metrics. Now, in the lead zinc plants that I was working with, we have a process called flotation. So I'd spent too many years thinking it was flotation, but it's not. It's flotation. And what it means is a really interesting process. Imagine it's like the bubbles that you get in your dish when you're washing the dishes. So the laundry liquid will split up the fat, and you'll see like oil and stuff floating around. Similar sort of thing. So you have these chemicals called reagents, which bind to the metal particles and float them to the top, and then it kind of just gets skimmed. So this little thing is spinning around, and these little bubbles of metal are kind of bubbling over the edge of the top of this tank, and they spin it at the bottom, and they put in kind of oxygen and stuff, and it makes bubbles, and they float to the surface, and all the valuable stuff actually comes out the top. So these reagents are pretty expensive, and once again, it's another balancing act between how much water you're putting in, how much air you're putting in, what's the balance of the different reagents, and you'll often get this kind of competition between the mine and the mill, where the mine will say, oh, we gave you high grade ore, or we're giving you really good quality stuff, and the mill's recovery is tanking because they're giving them either low grade ore, or maybe there's a different mineral composition that the reagents weren't good for. So it is this kind of weird balancing act between the different things. We also had, I saw a project get proof of concepted, which was a data science project at a particular mine I wasn't involved in, where they were trying to predict what they should be using in the mill and in the flotation in terms of reagents and stuff. But they found that the downstream data, so the estimated rock that they were getting, was actually not good enough to be able to say what was actually going into the mill, because you may be expecting high grade ore at this time, and the settings would be right for that, but they've actually mistakenly put a whole scoop of waste into the mill, and suddenly the recovery is going badly. And when we're talking about flotation, we've got, so as I talked about before, so airflow rate, how much air you're bubbling up through it, and then the grade of the concentrate. So they have things called in-stream analyzers, which kind of measure using magnetism or different types of sensors how much, what's the grade, what's the quality of the material that's there in the plant currently. Another process that's quite interesting is called electrowinning. So this is more for copper. It may be used for other minerals as well, but I just know about the copper. And what it uses is a solvent. So you've got this acid solvent mix that kind of flows through the plant, and then they put these big sheets of metal into this solvent and run electric current through it, and the copper particles actually attach to it. So these were not covered in copper before they went in. They were just a normal, I don't know what sheet of some type of metal, and they run the electricity through it, and the copper actually sheets onto it, and that's what they end up selling, these kind of sheets of metal that have had the copper particles bind to them through the solvent process. And because we've got that solvent process, we're going to measure how stable that is. That's the solvent is called electrolyte. So how stable that particular mixture is, because if you don't get the right chemicals, the things won't bind properly or they'll sink to the bottom of the plant. And then you measure how pure those sheets of copper are going to be, because you'll get different amounts of money from the people you're going to sell it to, depending on how pure your metal is. And then at the end of the processing plant, we're talking about recovery. Well, all of that stuff that you're not recovering is going to end up in your TSF. So your tailings storage facility, these are some essentially really big dams which get filled with all the waste material. There have been some really high profile things in like Brazil where they've had the TSFs kind of fail and all of this material has gone out, wiped out villages and stuff like that. So there's really strict regulations, especially in Australia, about how you store that material. And you can see again on here kind of how they sequentially raise those tailings storage facilities so they get higher. So this one up here wouldn't have started as high as it is. It would have been down lower, and then they've slowly added to it over time. There's new technology that's coming out where you can kind of remove the water from your tailings and you can store it in these kind of like big Lego bricks sort of thing and stack them up so you don't have risks of dams falling and the cost of extending those tailings facilities. And so in Australia, it's really, because of all the environmental restrictions, you're basically not allowed almost any seepage. So any of that tailings waste getting out, because you've got all those chemicals from the plant, which are quite harmful and they can't be released into the environment. So they have many stringent regulations. There's kind of dam wall monitoring. There's really cool seismic technology where they kind of have sensors all the way around and they have real-time reporting on what's happening to the dam wall, because if there's any sort of deviation, that gets raised as an alert straight away because you've got to inform the government, anyone nearby. Like it's, I don't think we've had any TSF failures in Australia that I know of anyway. I'm sure there were some back in the day, but these days there's a lot of regulation. And then the final product is what they call concentrate. So this is as it sounds, a concentrated product. So I believe that's probably zinc there. It was zinc oxide goes black. But they keep it in these big stockpiles of refined metal. This is the product that actually gets sold. So it can be as high as, 80%, 95% of a particular metal at the end of the process. And then there's some trade-offs between how wet it is because it's been through the plant, how heavy it is. So these ones here, I'm not sure what they're actually transporting, but if it was lead, because lead's so heavy, you can actually only transport kind of half. So the lead containers are much shorter than that. But you'll have this is an internal stockpile here, and he'd be driving around and depositing that into containers for later transport, just like you see in the picture there. And the concentrate is, where we make the money. That's the thing that gets sold. And so we've got sales revenue and we've got total production volume. Pretty basic stuff, but it's what really matters at the end of the day is the final stuff. So yeah, I had a lot of really lovely people spend their time with me over the years to kind of take me through all these different things. That the people involved in mining are super lovely and they love talking about all their kind of subject areas. So I'll just quickly go through my my recommendations for new people. So the best thing is to get to site. If you get the opportunity, obviously, it can be hard because you've got to do all the safety inductions and all that kind of thing. But the best thing that you can do is always get to site, meet the people. You know, they don't really want to spend the time getting to know some person from some corporate office that wants to tell them how to do their job. But when you get out there in front of them, they're willing to kind of share their craft, their sort of art, I guess. And on that, you know, you actually have to really trust the SMEs. And I think this applies in most industries. You know, as BI developers, we're always looking for data, but a lot of the time, the subject matter experts who work in that industry, the engineers, the geologists, the people in the processing plant actually really know what they're looking for. And a lot of the time, you can find the data that supports what they already know. And so it can be, you know, talking to all the experts is what I recommend in whatever field you're in. Embrace the engineered chaos. So what I mean here is you've got all of these unknowns, you know, from all of those pieces that I talked about. It's all an estimation. So you've got an estimated shape of the material. You've got an estimated quality of the material. You don't know how far you need to drive down the shaft. You don't know how long things are going to take, how hard it is. But that's kind of where the fun is. You know, you've got all of these crazy processes that are happening, and you just got to get involved and kind of do your best and get interested in it. And that brings me to the end about that's what I really love. I love the physicality of mining. I love that at the end of every data point, you've got people doing real world processes. You've got minerals going through this huge processing plant. You've got heavy machinery. You've got explosives. You've got all of this cool stuff. It's just so much more interesting than putting buckets of money into different, you know, columns or something like that. I just found my time in mining super fun, and I would recommend it to anyone who's up for it. Yeah. And that's the end of my presentation. Any questions?
I had a question. So, like, say when you have data to like, you have to like where the business and process. That's what I have right now.
Yeah, good question. So for the people online, the question was, did we have to work on changing any processes or installing new things? And yeah, I mean, luckily there's, you know, mine sites have electricians a lot of the time, so they do kind of all the wiring and stuff. But you've got like the whole plant, is all IoT. They have sensors for everything you can imagine. It all gets plumbed into like a SCADA system, and then you're sort of downstream from that. So it's constantly happening, and there's more and more of a push to get more IoT things happening out there in the mines. There's some really interesting stuff around the systems on the trucks that like Caterpillar and stuff are putting more and more sensors. You've got sensors in the tires to see how hot they are. You've got sensors on the chassis to see the vibration on the machinery. You've got sensors on the mill to track the vibration. Like all of this stuff is, and it's only getting more and more. One of the challenges you have with IoT, especially with mining, is that these sites will be out in the middle of nowhere. And trying to get real-time data is nearly impossible unless you're running like an edge device. And a lot of mining companies are probably not quite advanced enough to do kind of advanced edge stuff at this point, but it'll definitely be coming.
Starlink.
Yeah, potentially, yeah. Yeah, I don't know. That's a good point. Any other? Yeah.
Great presentation, very in-depth.
Thank you.
I don't know if this question might apply, but how do you maybe increase the usage of Power BI reporting in the organization, especially with the senior management?
Yeah, it's a good question. I mean, it's the same question that you face in every organization, really, and I think it's about finding champions and making their life easier. So we talked about the shift bosses. So if you can convince the shift boss that he can do his job easier, he can get all the information he needs, then he's going to drive it because he has all of the information. He doesn't have to refresh an Excel spreadsheet. He doesn't have to do this stuff. You're making his life easier, and then he'll drive adoption. In terms of the executive, that's kind of harder because they have their own agenda. I haven't had great success in getting executives to do things that they didn't want to do. But you can, if you can show value, if you can give them what they want, then they'll use it.
Mine is very specific, but there's some interesting elements that can probably relate to the funding issue. Are you finding that easy to do with the transition from mining, using that background and mindset with other things that?
Yeah, well, I was actually really surprised in starting with utilities how many similarities there are. You know, you've got SCADA systems tracking the electricity through the grid. You can treat the electricity a lot like a processing plant because there's different materials that the electricity is going through. You know, certain wires conduct better than other wires. You've got with the energy transition, you've got things like all the renewables that's going in. You've got new infrastructure getting put up. You've got field people going out there and doing maintenance on the substations and the wires and all of that. So there are definitely more similarities than I thought there would be in utilities. But I'm definitely passionate about staying in areas where it's not just finance. Yeah.
I just found your presentation very interesting. And what I also found interesting is the choice of color on your chart. Like, do you have a standard theme for your Power BI reports, or do you get to pick the color by yourself?
I wish I got to pick my colors myself. Most of the time, it's the corporate theme that you've got to go with. My current corporate theme has some fluoro pink and some fluoro green in it, so I'm probably trying to stick away from that. There's a really cool site called Color Picker, and it has kind of all the different colorblind friendly. You can pick if you want just 2-color, 3-color, etc. So I usually pick something like that, and I try to just kind of logically theme it with what I'm looking at. Good question.
I'm just wondering about specific projects that we've worked on that you felt sort of really engaged the stakeholders and sort of got them enthusiastic about how they can use the data.
Yeah, so the shift bosses were some of our best clients because they, especially we started rolling out kind of iPad, well, not iPads, but Android devices to them, and being able to pull up Power BI straight and see right now what's my performance of my guys. Oh, Barry is there. He's once again doing his 40-minute second last trip, and call him up on the two-way and say, hey mate, come on, let's move, because you get near real-time data into these systems. The particular one we were using is called PitRam, and as soon as they pulled up the operator to say, hey, I'm loading X truck, it would go straight in the system, and we could in near real time, so doing kind of micro batches, get that information out. So you've got between 3 and 5 minute delay between it, but it's plenty of time to follow Barry up. But also having the in where they do the shift changeover, we've had some big screens up just showing kind of the last shift, how it was, and the different crews, so that they could actually see, oh, that other crew, we're doing better than them, and kind of instilling that kind of competition between the different crews was good. Yeah.
you visualize data, sometimes like sensors may malfunction and then you need to some data or something. So do you like impute the data? Do you use some models before visualizing the same? Or how do you?
Good question. In general, my approach is fix it at the source. You know, if there is an Greg's cheering, but if there's an error, like the worst thing you can do is to cover it over because then you get made responsible for it. And at the end of the day, as the report developers, unfortunately, we end up being the first line that gets called. Someone goes, the data's wrong. And you kind of go and look and you say, well, no, my report's fine. Where's the problem? And then you've got to go find the right people. So I would steer away from saying or trying to estimate the values. We can leave that to the data scientists. For me, I prefer to just throw a big red error saying this thing's broken. It's not my fault. Fix it. Cool. Oh, sorry.
In our organization, there's a lot of requests to extract the order like the report. And we sort of go to the 40 other stuff. So like a little Excel file CSV file. Maybe you have to send home.
Yeah, I mean, you do definitely get those kind of questions, but what I usually do is I'll give them, especially when I'm first developing a report for them, I will kind of put an extract at the back that they can get to. It's just like a tabular dump that if they really want it, it can be there. But then I make it all of the front pages, be all the pretty visualizations and stuff, so that when they land on the report, they can get the high level view. But then when they don't believe it, they can go and extract the data from like an audit page or something like that at the back. I try to steer people away from those extracts, but at the end of the day, as BI teams, we need to do what the users want. And if they want the raw data for their own spreadsheet, okay, give it to them. And I also find that being consultative when they get it wrong is really valuable and gets them on side. So, you know, they'll be doing their own magic spreadsheet. And instead of saying your data's wrong, you can just say, oh, I noticed, you know, our thing is not quite the same. Do you know what that might be? And then they might look through it and say, oh, actually, I've made a formula error on this part, and you can slowly bring them along, but it's hard.
There's another small issue that is there's a limitation on how many we've got a different export out from the table review.
Mm-hmm.
So sometimes I do that to have to build a company report in order to show that many report out. Do you limit the user on how many you can see, or you just go crazy with a couple of years of recording?
No, it's a constant balance. But I mean, as someone who got on the Power BI train early, I got pretty good at telling people no to stuff, because back in 2016, there was heaps of stuff we couldn't do. And so I used to just say, oh, you know, can't really do that because, you know, you trade some ease of use for that flexibility that you want. So can't do it. Sorry. And it's just kind of a limitation. I try to push things more back to the source system. If they're trying to extract all this information, get it from the source system or pull it in with Power Query or something like that. I try to handle their requirement outside of the Power BI report.
I'd like to thank you very much for sharing. Yeah, it's very interesting. My question is around data collection and data storage. I am very amazed of how many steps are there or phases are there. And I suppose like each phase will produce a lot of data, right? Like for the mining companies, how do they collect the data? So they have a centralized data warehouse for this for everything. And when you create a Power BI dashboard, do you connect that Power BI with various different systems, or maybe a centralized data warehouse? Yeah,
That's a good question. So the question for those online was, how do they store all this data in mining companies? And so I'll just talk through what we are at the top.
Yeah, we're fine, mate.
Yeah,
No worries.
cool. Yeah, so the way it worked for the mining companies I worked for, they had on-site data centers, which ran all of the on-site systems. So you'll have a transactional system which is recording all the cycles and all the things that are happening. So sometimes that can be automatic. So the different trucks will talk to each other. You know, you'll have a weightometer on the bogger, which is saying I'm putting 20 tons into this loader, into this whole truck and taking it out. But in the older ones, especially if they're like really deep where connectivity is really hard, they have like two-way radios and they kind of call up a little call center and they say, I'm Barry. I just got my 20 tons from Sarah and I'm at this location with this time, and they just kind of key it into the transactional system. And so you'll end up with that cycle being recorded with where they were, how many tons they had, kind of like any other sort of transactional system. But then you've got additional things. So you'll have the OEM. So the truck will have like a synchronization to the Caterpillar cloud or something like that. And so we end up with a lot of different source systems internally, which what we were doing is we were extracting them all into Azure. So we were, depending on the different source systems, if it was the Pi Historian, so that's where all the sensors go. The sensor goes into SCADA, from SCADA into this thing called a Historian, and we would pull the data out of this Historian into storage, and then we'd process that from Azure Storage through Databricks and then into Power BI. Or the transactional system for kind of all the trucks with all those processes. We would micro batch that out. It was just a SQL server that kind of recorded it. And we would, once again, put it in storage. We had a metadata-driven framework, and it would just be storage, Databricks, Power BI.
Awesome. I think that's it. That was my question as well. So I'm glad you asked that. How good was that? I love those types of talks where we get to see a little bit of real world stuff. And I think, you know, the allegory of mining and data is so nice, right? We follow a similar kind of process. We go and blow up some data and then, you know, sift it and turn it into insight. So that's really cool. I really appreciate you doing that talk. And if anyone else has a talk like that, where you can show us some cool things you do in your industry, I'm very interested. We'd really appreciate anybody that can provide insight into industry type stuff, because to be honest, they're the best talks. It's all well and good for me to come up and tell you about what's happening in Power BI and theory, and we can get Marco here to tell us about DAX. But I think those talks where we see real world case studies and client solutions, they're the ones that I think people get the most value out of in this community. And so if you've got those sorts of talks, please let me know. You don't have to be an experienced speaker. Everybody's friendly. It's all good. And if you want to just do a short talk or a lightning talk, we can do a lightning round type thing as well. Anyway, awesome. Thanks, Michael. Really appreciate it. Yeah, let's give him another hand. All right. So July we've got coming up, and then we've got a double special in August. We've got Reza and Marco both coming in the same month. Okay, so I was like going to make it so that, you know, I had to tell Reza no because we got Marco, and then I was like, people are definitely going to come to both. So we're going to run 2 in August. I'm not sure about July. It sort of just depends on if we can get a speaker secured for July in the next week or so, then we'll run July as well. But we might save it for the big double special in August. So that'll be fun. So that's yeah. Obviously, Marco's going to talk about DAX, and I've asked Reza to do something on Fabric. So that's what those guys, and that's pretty much what those guys have been talking about. Reza's on a world tour at the moment, going all the way around the world talking about Fabric. So that's what's coming up. I've got some other things in the pipeline as well. That will be coming up later in the year. I want to do some more talks like this. I want to do executive roundtable talk as well, which is always interesting as well. So yeah, we'll try and get those organised. But heaps coming up. Hopefully, we'll see you next time. Thanks, and yeah, we'll see you next month. Thanks very much. Thanks online.